So this video is going to be on the basics of organic mechanisms. We will talk about some of the elementary and fundamental steps of a mechanism. We'll also talk about some of the definitions and some of the symbols used that you'll need to know to understand mechanisms in future. But first of all, what actually is a reaction mechanism? So in organic chemistry, it's defined as something that shows the movement of electrons in a step-by-step fashion from the reactant to the product via intermediate reactions. So, as you've gone through chemistry at GCSE and just started A level or equivalent, or you may be researching this yourself, you may think a reactant reacts with whatever's in the solution with it to go to a product. In fact, that's not true. A reactant doesn't go straight to a product. It will react with what's around it to form an intermediate. It's called I1, intermediate 1. That could then go and react with what's around it to form intermediate 2, which will then finally react with things around it to form the product. But the key point here is that the reactant doesn't go straight to the product. It will have intermediate steps. It could be 1 intermediate steps, it could be 100, it could be any number, but there are intermediate steps. So a reaction mechanism actually shows the movement of electrons, the breaking of covalent bonds, the construction of new bonds and things like that. It shows you how the electrons move to form each product. And this is very useful when you're trying to synthesize things like pharmaceutical drugs, like paracetamol that you may know, or life-saving drugs for the heart. You need to know how this works to get it right. So, if we start with some of the symbols and terms used. So first of all is heterolytic fission. This is defined as the breaking of a covalent bond with both electrons going to one of the atoms, forming a cation and an anion. So fission is defined as the breaking of, so the fission of covalent bonds. Hetero means different, with both electrons going to one of the atoms, forming a cation and anion. So the products are different. You've got a cation and an anion, two completely different charges. Hence hetero, so heterolytic fission. Homolytic fission is the breaking of a covalent bond with one electron going to each atom, forming two free radicals. So again, fission is breaking, so the breaking of a covalent bond, the fission of a covalent bond. And homolytic, homo means the same, with one electron going to each atom. So at the end of the day, you're getting two identical free radicals if the two atoms are the same, of course, but the point is you're getting two radicals as one electron's gone one way, one electron's gone the other. But how do we actually denote these when we're doing mechanisms? So there's something called curly arrows. So heterolytic fission is denoted by this double-headed curly arrow, while homolytic fission is shown by a single-headed curly arrow. Now, a curly arrow shows the movement of electrons. So a double-headed shows the movement of two electrons, each side of the head representing an electron as such, whereas a single-headed arrow shows the movement of one electron. So just to recap, a curly arrow shows the movement of electrons, double-headed means two electrons are moving, whereas single-headed means one electron is moving. If we go on to dipoles, you may have heard of dipoles before, but just in case you haven't, I'll just quickly define them. Dipole is a small charge on an atom, denoted by the symbol delta, that represents the electron distribution in the bond, usually due to the difference in electronegativity between atoms in the bond. So in case you don't know, this is the symbol of a lowercase delta, and the charge will be placed here, so if it's positive or negative, so if it's positive it'd be delta positive, if it's slight negative charge it'd be delta negative. So if we look at, say, a hydrogen, dihydrogen molecule, it looks like this. You have no charge associated with it because you've got two identical molecules. Nothing can be more electronegative than itself. If we look at something like HBr, now bromine's more electronegative, giving it this slight negative charge, and hydrogen's slightly electropositive compared to bromine, so it has this slight positive charge. And the way you can think about what has the negative charge, what has the positive charge, when you're looking at electronegativities, is you've got this bond, say dihydrogen, and you've got this bond, HBr. Now, you've got these electrons. They're dead center in hydrogen because the hydrogens are identical. If you think Of these electrons, because they're negatively charged and the nucleus of a hydrogen is positively charged due to protons, if you think of this as a steel ball bearing, the electrons, and you think of these atoms as a magnet. Now if you have two identical magnets and you place the steel ball bearings in the middle, they're just going to stay still. They're going to stay dead center where you put them because the magnets have the same strength. Whereas if you look at HBr, if you put ball bearings in the middle, denoted by this dotted line, bromine has a higher charge density, has a lot more protons in its nucleus compared to hydrogen, meaning it's like a more powerful magnet as such. So you've got a big magnet against a small magnet. Now if you put the balls in these steel balls, or the electrons in the center, it's going to be attracted to the bromine more than the hydrogen, so it's going to go ever so slightly right. And because of this, it gives bromine a delta negative charge and hydrogen a delta positive charge. Because if you think about it, electrons are negatively charged, so if they're slightly towards one atom, that atom is going to become slightly more negatively charged, while hydrogen has lost some of its electron density, meaning that the hydrogen is going to be slightly positively charged. Think about it, dihydrogen, when you're sharing two atoms, has no charge, so if you lose a little bit, it's going to form a delta plus, whereas if you lost all of it, it would be a full positive charge. And that's what dipoles are. They're just showing a partial charge on an atom. And this is related to the electronegativity of that atom. So how do dipoles relate to reaction mechanisms? So if we look at the example of HBr again, with delta negative and delta positive, if this bond was to break heterolytically, the electrons would move from that bond to the bromine, shown by this curly arrow here. So again, curly arrow shows the movement of two electrons with double head, and the electrons move from this bond to the bromine. This can be induced by things like a carbon-to-carbon double bond in an alkene. Because hydrogen is slightly positively charged, it wants electron density. There's a big electron density here, so it kind of forces it to break so it can attack into the carbon, forming something like this. And I'll show you the actual reaction mechanism in a later video. So that's how it relates, is when you break a bond heterolytically that has dipoles, the electrons will move from one atom, from the bond to one atom, the one with the negative charge, as it's closer. It would be like moving those electrons, it would be like trying to fight a more powerful magnet and travel further to go to the hydrogen, or you could take the easy route where it goes towards the strong magnet and hasn't got to travel very far. That's how I think of it, and that's a really good way of thinking of it. It's a simple way of thinking of it. So there are different types of reaction mechanisms in organic chemistry: electrophilic addition, nucleophilic addition, electrophilic substitution, elimination, and some radical reactions, addition and substitution being one. Now, initiation, propagation, and termination, they're ones that you'll need to know at A level, if you're doing A level or equivalent. Electrophilic addition is also one you'll need to know, and electrophilic substitution is also one you'll need to know, but I think that comes more into A2 when you are doing things with benzene, reactions with benzene. So, just a brief summary of what this means on this page. So addition is adding something in. Philic means you like it, something it's liked. Electro, think of an electron negatively charged. So here, electrophilic means it likes negative charge. It likes electrons, likes a negative charge. Addition obviously is just adding in. So electrophilic addition, you would take a molecule or atom that likes electrons and you would add it into there to form a new bond. Nucleophilic addition is the other way around, so something that likes a nucleus would be added in instead. Electrophilic substitution, so something that likes electrons, something that likes a negative charge, actually just substitutes out another atom instead. Elimination is in the name, it eliminates something. It eliminates a small molecule such as water or HCl. And radical reactions, if you remember earlier, a radical is something that has an unpaired valence electron and is usually really reactive. Now these can either add in, substitute, or initiation, propagation, termination will be something I discuss in more detail later. So you have the initiation, a radical is made, a propagation where the radicals go on to react several times, and termination where the radicals react together to stop any further reactions as such. Now, like I said, look at other videos on my channel later on, where I'll actually go through each of them and show the actual mechanisms behind them. So I hope this video has been helpful. You now know the basics behind mechanisms, what the curly arrows are, some definitions and things like that, and now you know which ones you need to look at if you're doing A-level, for example. Thank you for watching. Please like and subscribe. Let me know in the comments below or send me a message if there's any topics you would like me to cover that I haven't already. Thank you.